As we've learned all these methods for quadratics and solving them, we're going to go into word problems, like some area word problems. We want to find the value of x if the area of a rectangle is 78 square meters. Well, I can use the area formula, which is area equals length times width, and substitute in what I know. Well, I know my area is 78 square meters. So 78 equals the length, which is here, or the other one, doesn't matter which one you pick, x plus 7. And I'm going to keep it in parentheses. Our width is x. I'll notice I can FOIL this because it's by itself. So I get x squared plus 7x equals 78. I have options here now on how I want to solve it. I can factor. I can complete the square because c is already on that side and it's not a perfect square. I can put it in standard form, use quadratic formula. Go ahead and choose whatever you want to. If you want, you can pause the video here before you see what method I use. I'm actually going to use factoring. So I'm going to bring my c over to the other side. I know that the factors -6 and a positive 13 will work. So x minus 6 and x plus 13 because they sum to a positive 7 and multiply to a negative 78. When I do solve it, I get x equals a positive 6 and x equals a negative 13. It is not possible to have a negative measure, right? That doesn't exist, which means the value of x is going to be 6, and don't forget your label, meters. Go ahead and try number 2 before I show you the answer. Here's the answers to 1 and 2 with all the work there. Other times I might not give you the display for the graph, the diagram like I do here in the problems numbers 1 and 2, but you should still be able to solve these problems. So let's go ahead and try number 4. Number 4, I don't give you a diagram. So you can draw that in, right? I have a rectangle. The dimension of the rectangle can be expressed as, ooh, that's not a rectangle. Let's try that again. All right, well, you get the gist. It's not working perfectly, but it's fine. All right, you have an x plus 3, and then you have an x minus 8. It says if the area is 60, then find the value of x. So 60 equals, well, it's x plus 3 length times the width, x minus 8. I can't just solve this because remember, this is not 0. I actually need to go out and FOIL it. So 60 equals, once I FOIL it, I'm going to get x squared minus 5x minus 24. I can complete the square by bringing the 24 over, set up a perfect square trinomial, or I can factor, go from there. What I'm going to do is I'm going to factor it because if I bring 60 over, I get 0 equals x squared minus 5x, and I'll get a negative 84. Well, I know I can split this between a 12 and a 7, so x minus 12, x plus 7. So x is equal to a positive 12 and x is equal to a negative 7. But negative 7, you cannot do that, meaning our value for x is 12. And you can write 12 inches, however you want. And this is also the answer number 3 in case you did that. Other times we might apply this to when we have shaded regions on the next page. If the area below of the shaded region is 59, so 59 is equal to whatever this is subtracted by whatever this area is, right? So 59 is equal to, let's edit this color, let's make this pink just so we can visually see it. We're going to take it in parentheses, brackets, and then parentheses. 2x minus 1 times x plus 6. Right, that's the entire outside of the rectangle. We're going to subtract it by that small missing piece in the middle. So brackets, x times x plus 3. So we're going to individually solve these. And whatever you get for x, you'll plug it in to figure out what the dimensions are. Go ahead and pause the video and see if you can actually solve this. It just looks long, but it's still the same rules of calculating, using order of operations, and then using what we know about all the various methods for quadratics. Pause the video here. And let's check your answer now that you've tried that problem. You should have gotten 9 by 11 because x ends up being 5. If you did not get that, there is more practice for you on the next page. There are other word problems that we will do that are not just area focused. They're actually consecutive integers. Well, this is when my little chart came in handy, right? Because it says the product of two positive consecutive integers. Okay, so I have integer 1, or first integer, and integer 2. I also have my total. Do you guys remember making this tic-tac-toe type of visual? So my total is 56. Well, if the first integer is x, the next consecutive positive integer is going to be x plus 1. So I take x plus 1. The difference here now is I'm not summing these. I'm doing a product of these. So it's x times x plus 1. So I get x times x plus 1 is equal to my 56. So I get x squared plus x equals 56. Let's go ahead and factor this. You'll find out that x is equal to a -8 and a 7, but -8 is not a positive integer. So your answer is actually 7, and then the next consecutive positive integer is 8. That is your answer. So be careful with what your final answer is actually going to look like. Go ahead and try number 3. Now be careful, the wording for number 3 is different from what we just did. This says odd integers, right? So we're skipping one in between. Go ahead and try number 3, and I will display the answers. Pause the video here. And so the answer for number 3 you get is 3 and 5. You set it up this way. Check your work as you go about. The last category, so we did area problems, we did consecutive integer problems, it's called projectile motion problems. Yes, things that you literally send across the room or up or whatever the case is, right? This has a lot to do with physics. So let's see this. It says a soccer ball is kicked from the ground, right? So if we're thinking about this visually, it's kicked from the ground, it's kicked up with the velocity going upward. For a second, it hits the maximum part and then it goes back down, right? It wants us to find the maximum part. And usually these parabolas are fairly even theoretically, right? What we want to figure out is how many seconds will it take for the ball to reach the ground? Our grounds are kind of like our x-intercepts here. So we're going to use that formula of finding your y, of seeing out, well, what is the y? How many feet did it go? And then figure out our distance. What we can also do is we can figure out how far something went. We want to figure out the maximum height and how many seconds, right? So if you think about it, our y is our max height, and our x is our seconds, right? So it's like your AOS. Well, I have this formula, h equals -16t squared plus 90t, and h is after the number of seconds. So what I can do is substitute this into the quadratic formula to figure out our x. So we have x equals -b, which in this case is 90, -b plus or minus, yes, you're going to have 90 squared, minus 4 times a, which is a -16, times c, which is 0, all over 2 times a, which is -16. Go ahead and solve this. When you do, you're going to be able to use your calculator. You get something like -180 over 32. You get 0 over, sorry, not -80, you get -80 over -32. And then you get 0 over 32. So 1 is 0, right? And when we drew our graph, there is something that's at the origin and goes up and it goes down. We're trying to look for this. When does it come back down? So Our answer is actually 5.625 seconds. Yes, you can use your calculator to get that decimal. Now, we just found this part. We still need to find the maximum height. You can go ahead and plug it back in and solve for what is h or y. You could also just use your formula for y, which we haven't used and a lot of you haven't memorized, but it is c minus b squared over 4ac. Sorry, not 4ac, 4a. So we're going to substitute it. C is 0 minus b squared, which is 90 squared, all over 4 times a, which is negative 16. You're going to find out that c is about 126.56. So we're going to put our label because it will travel 126.56 feet in 5.625 seconds. I know that was a lot, but technically nothing was new here. We're just deciphering from the problem, like, hey, you gave me the equation. How do I apply this to find out certain things? Go ahead and try number 2. Pause the video, but it's the same type of problem. I'm going to show you the answer to that. So it displays number 1 and number 2 at the same time, so you can check it as you go. Other times, these problems might not say how long does it take to reach the ground. Other times it might be like, well, let's see. It says a penny is dropped off the Empire State Building. Okay, cool. So we have our Empire State Building here. The penny goes from here, and it falls all the way down. Great. If a penny can be modeled by this equation, right, so that's the path it took, how long will it take to strike a 6-foot person? So now I'm not looking at the ground. This person's 6 feet tall, so this is this tall. I don't want the ground. I want it to see 6. You have to then realize that, you know what, I'm not setting my equation that they give me equal to 0. Think about it. I'm not hitting 0, the ground. I actually want it to be equal to 6. So you have to be very careful in solving these and make sure you're solving it correctly. In this case, it wants you to find the x and the x-intercepts or the roots of the solutions because it wants to say how long will it take. Usually seconds is your x and the distance is your y. So go ahead and solve this. You can probably use square roots because there's only one variable, right? That bx in the middle is missing. Go ahead and pause the video while you solve it and then check your answers. Here is the answer for that problem. You get about 8.82 seconds. It's not positive negative, it's just positive because there is no negative time. We're not going into the quantum realm here. Go ahead and continue to practice with this. I know it's a lot, so please make sure you continue to check your answers as well.